A plastic sleeve of outer radius 1 mm covers a wire of radius 0.5 mm carrying electric current. Thermal conductivity of plastic is 0.15 watt per meter Kelvin. The heat transfer coefficient of the outer surface of the sleeve exposed to air is 25 watt per meter square Kelvin. Due to the addition of the plastic cover, the heat transfer from the wire to the ambient will option A increase, B remain the same, C decrease, or option D be 0. So in the problem is given that the wire is of 0.5 mm radius and the plastic sleeve is of outer radius 1 mm. So the plastic here is the insulation provided to the current carrying wire. Now one thing here to understand is that the insulating material are added to decrease the heat loss through the cross section. However, this addition of insulation does not guarantee that there will be a decrease in the heat transfer, since the addition of insulation has the following effect on the resistance of the heat flow. So the first effect we can write, let's write here. The conduction resistance increases due to increase in outer radius. Since the outer radius of wire from 0.5 mm is increased to 1 mm, the total radius, outer radius. So what happens? The conduction resistance increases because there is increase in the radius, because the total diameter has increased. And the second effect is the convection resistance will decrease because the surface area of heat flow has increased, right? Suppose if we consider this as cylinder, so the surface area of wire will be AW is equal to 2 pi 0.5 into the length, and now since we have coated it with plastic, so the new surface area will be 2 pi 1 into L unit square, of course. So we see here that the overall surface area will increase, and since the surface area is increasing, the convection resistance will decrease. Therefore, the critical thickness of the insulation at which the heat flow through the cross section is maximum, but beyond this thickness there will be a reduction in heat transfer. So let's write the statement here. The critical thickness of insulation at which the heat flow is maximum, but beyond that thickness there will be reduction in heat transfer. There will be reduction in heat transfer. So for cylindrical cross section, the critical radius RC is given by K by H, the thermal conductivity of wire divided by the coefficient of heat transfer. So this is for cylindrical wire. Cylindrical shape, let me write, or cross section. And it is RC is equal to 2 times of K by H for spherical cross section. Okay, so using this formula we can write, therefore RC will be equal to K by H of plastic, because plastic is the material used for insulation here. So this will be equal to 0.15 divided by H, whose value is 25, and this will be equal to 6 into 10 to the power of minus 3 meter. So RC in millimeter will be 6 millimeter. Therefore, RC is greater than R naught, which is 1 millimeter. Therefore, the addition of plastic increases heat transfer. So because of addition of plastic, it will increase in heat transfer, and that increase will be up to 6 millimeter, and beyond which it will decrease the heat transfer. Okay, because the critical value of radius we have got is 6 millimeter. So from here we can say option A is the correct choice. For detailed information, you can refer to the NPTEL course lecture number 1, Introduction and Fundamental Concepts on Conduction and Convection Heat Transfer by Professor S.K. Som of the Department of Mechanical Engineering at IIT Kharagpur.